At Siam Exhaust, a typical customer order takes 45 days to fulfill. If you ask the factory manager why, they'll defend that timeline as a necessary byproduct of a complex manufacturing process. They'll walk you through the labor-intensive steps, precisely cutting raw pipe, bending it to spec, welding the joints, and finally, painting and inspecting the finished product. But when you actually time those steps, the math tells a different story. 5 minutes for cutting, 10 for bending, and 25 for welding and painting. The actual physical work on the product takes exactly 40 minutes. This creates a massive discrepancy. 40 minutes of active work is buried inside a 45-day delivery window, leaving over 1,000 hours of time completely unaccounted for. For Siam Exhaust, the bottleneck wasn't a lack of effort from the workers. The inefficiency was hiding in the massive, unmeasured gaps of idle time between those 40 minutes of production. To fix these delays, many managers look to tools like this, a high-resolution, computerized flowchart. These charts often represent a theory of how work should move in a perfect environment. They rarely account for the physical friction and unpredictable pauses of a real-world factory. To find where that missing time is actually leaking out, you need value stream mapping, or VSM. It's an X-ray of the entire operation that reveals the hidden obstacles traditional charts miss. You cannot fix a real-world, three-dimensional bottleneck by studying a two-dimensional theoretical map. The first rule of VSM is to leave the office behind. Investigators must step onto the gemba, the actual place where the work happens, with nothing more than a pencil and paper. The mapping process is counterintuitive. You don't start at the beginning of the assembly line. You start at the very end with the customer and map the entire journey in reverse, working your way back to the raw materials. As you walk backward, you record what you see in the moment, counting the actual parts sitting in bins and timing the machines with a stopwatch, rather than relying on the numbers in the company handbook. Walking the process in reverse reveals where the physical reality of the floor diverges from the data stored in a central office. A value stream map builds diagnostic power through 3 layers. Layer 1 is material flow, tracking the physical movement of parts and highlighting stagnant inventory. Layer 2 is information flow, mapping how orders are processed via emails, software, or paper slips. Delays are often caused by information. An order waiting for a signature is as damaging as broken machinery. Next, we add the timeline. This jagged scale separates value-added time from non-value-added time. This current state map exposes being visible time sinks. This bird's-eye view makes it clear. The missing time isn't being lost during the work itself. It's trapped in the mismanaged gaps between departments. Once the gaps are identified, the team uses Kaizen bursts, targeted, rapid improvements, to strike directly at the largest pockets of wasted time. Siam Exhaust used their map to identify these gaps and responded by physically dismantling the walls between their departments. They moved their isolated machines into a U-shaped cell for continuous flow and used a Kanban system to pull inventory through only when the next station was ready. They achieved higher velocity through a smarter system design, rather than simply demanding that their employees move faster. The results were dramatic. By eliminating the invisible waiting time shown on their VSM, Siam Exhaust reduced their 45-day lead time to just 5 days. Managing a business without value stream mapping is like a surgeon operating without an X-ray.
You risk cutting out healthy tissue while leaving the underlying disease completely intact. The numbers on a VSM provide an objective roadmap for continuous improvements to stay competitive. But even with a map, the physical workspace must be capable of supporting this new speed. Next time, we'll look at the 5S system, a framework for organizing the physical environment to sustain high-speed flow and prevent these massive waiting times from returning.